Programming Throwdown, Episode 99, Squashing Bugs Using AI and Machine Learning with Boris Paskalov. Take it away, Jason.
Hey, everybody. This is a really fascinating topic. I think there's been a lot of interest around using AI to sort of help developers. We've all had apps, even like super popular apps like the Uber and the Google app and other apps where they have bugs and they crash and things like that. So even the people who are the best at this have tons of issues. And so it's becoming a really interesting area. And we're so fortunate we have Boris Paskalov, the CEO and co-founder of DeepCode, to kind of sit down and roundtable, how we can make software better. So Boris, why don't you kind of start off by telling us like a little bit about your background, what was the idea or the inception of DeepCode and kind of at a high level what I was doing right now.
Sounds good. So welcome everyone. Thank you for having me. So my name is Boris Paskalov. I was originally born in Bulgaria, and I did my bachelor's and master in computer science in Boston, and then worked with a number of different companies as a developer. Later on in my life, I did an executive MBA, so I started moving into project management, program management, and many different things in that space. And I'm still working in technology, but I'm coding less and less, as you can imagine. So about DeepCode, obviously, the idea is that it started in 2016, and it's a spin-off from ETH Zurich, which is the #1 tech university in Europe. I usually call it the MIT of Europe when I make fun with the guys.
Nice.
But yeah, the idea is that my other two co-founders, Professor Dr. Martin Vechev and Dr. Veselin Raichev, so they spent about 12 years together researching the topic of learning from big code, so program analysis and how we can really apply powerful machine learning algorithms on top of code. And they've published many papers, lots of awards in the space. And after our CTO, Veselin Raichev, finished his PhD, pretty much the idea was clear that we have to start that as a new platform that should revolutionize how software development works over time. So that's really the passion behind it.
Cool. So let's unpack a lot of that. So you were a software developer, and then at some point you made you went to like a business school. What sort of inspired that?
Ooh, that's an interesting question. I think it's a consequence of many events, but slowly as a software developer, I started kind of project managing the software I was dealing with, kind of delivering it to the end users and kind of working on the end-to-end, trying to actually get specifications from them, understand how we test it, obviously making sure there's less and less bugs, making sure that we fulfill the right requirements. And kind of in my head, slowly, I start building this overall picture that it's not just the software, but it's an end-to-end process. So I start project managing some of those, then they start giving me larger projects with more people, and then all of a sudden the project became, hey, build a software that actually runs this robotized production line. And then this is how I ventured outside of the software space. And then eventually I just had projects like, can you open our development office in Switzerland? And that's how I kind of moved into non-software projects. And eventually I said, well, then I really to do that successfully, I need to learn a bit more about that side of the world. And hence I did an executive MBA.
Cool, that makes sense. So, this is something I've always wondered is, what do you think about the idea that at what level do you not need to have a technical background? So, for example, does a line manager need to be technical? A line, engineering manager? Does the director need to be technical? And at what point do you say, okay, this now has transitioned fully into project management, from process management from like a business perspective?
That is a very polarized topic. I mean, as a techie, I obviously believe that everybody should have technical understanding and background, just because this is where you learn basic logic, let's put it that way. Start thinking more like a machine than a person, to put it that way. And I think everybody should have a little bit of that. I mean, clearly, when you go into the arts, etc., there is quite a big range that you might not need that. But for anything, when you're working in the business world, you need some kind of a technical background, being that pure math that can actually lead into the same way of thinking. But with that said, there's many exceptions. I had many colleagues that didn't actually have any technical background. One of my very first technical manager, brilliant developer, he actually has a PhD in literature, right? So, yeah.
Wow.
So there's plenty of exceptions in the rule.
Yeah, totally. I mean, we have a lot of folks listening who maybe they started listening when the show started, I don't know, Patrick, 8 years ago or something, but and they have all sorts of different degrees and backgrounds. And one of the awesome things about this area is that it's so easy to pick up. You don't need to have a really long apprenticeship. Actually, I was reading something that if you're a hand doctor, it's actually one of the hardest professions to pick up. It's yours. So in software, you could do it in I mean, it's a craft, so you have to develop it like any craft, but you can at least get started quickly, regardless of your background.
Yeah, I think we just actually hired a junior software developer that had zero background in software development. Like a couple of years ago, he said, "Hey, I just want to be a developer," and he started picking it up. And I think with modern languages and frameworks, it is getting easier and easier to get into it, which is great. And there's a lot of tools that can help you along the way.
Cool. So let's go into DeepCode. So you were talking about this person, these two folks who were doing some academic research on code analysis. And one of the things I think that's hard to grasp for a lot of people is how do you do analysis on code, right? I mean, you can imagine, I guess you have to get rid of all the white space, right? But it's this sort of really complicated language. It doesn't have clear parts of speech. So a lot of NLP techniques, it's not obvious how they would work here. And so how does one even begin to sort of programmatically understand a C++ file? Like, how does that actually work?
It is a very, very good question. And the short answer is it is very hard. But you start with extremely good developers. That's the number one thing. I think both of our other co-founders, they're really they're language agnostic. They can literally do anything. They understand the languages inside out. Because the majority of the problem is program analysis. I mean, it's a pretty old type of thing that it's not very sought after today, but it's kind of gives you the core of what it is. So let me just walk you high level through the process of what it is. So first you start with parsers. So for each language there is a parser. So you actually use one of the standard parsers, maybe small changes here and there, but that's about it. And then a lot of tools pretty much end up here. They just minor adjustment because the parser gives you an abstract syntax tree or AST. And then people work on it. But the ASTs are not rich enough. They don't really represent everything that you need in the program, as you said, very complex. So this is where kind of the magic starts. We actually use proprietary solvers that actually extract every single semantic fact in the program, every single interaction, every single function, every single variable, every single object, and we build the relationship between them in terms of who is calling who, how is it changing, are you casting something to something else, etc., etc. So this actually goes into a graph index that actually represents this whole interactions of the code. And this is kind of the key piece, right? And this graph index has to be pretty much in a machine learnable format, right? So then you can apply machine learning on top of it. So that's kind of where most of the magic is, to create a machine learning representation for code, which is pretty much does not exist today, or if it exists, as you said, it's treating the code as string, as text, which obviously drops down all the semantic facts that are interesting about coding. And after you have this machine learning representation, then it's all about speed, efficiency to kind of learn from every single fix ever made, every single line of code that exists out there, and then apply machine learning algorithms to extract specific facts, right? And this actually brings you to have this knowledge base of everything that ever happened, how people have fixed different things, are there consensus how to fix them, are there people fixing it in totally different ways, and then you can actually assign probabilities of what problem is likely to be fixed in a specific way versus in another way.
Got it. Okay, so let me see if I can unpack this. So similar to sort of the grammar parsers, if folks listening remember that from grade school, how you would have the sentence, the man went to the supermarket, and you'd have to diagram that sentence, and you would you'd separate out the subject and the verb, and you draw this little graph to represent that sentence. You can do the same thing with code, and then I guess, but that by itself. So can you explain a little bit what has to happen to turn that syntax tree into a machine learnable format? So in other words, why couldn't the machines just learn on the syntax tree? What's missing there?
So it's missing a lot of the interactions and the depth. For example, you cannot track. For example, you have an object, you put it into an array, right? And then you actually get this object out of the array. The abstract syntax tree will not be able to tell you if it's the same object, right? So the idea is that you have to have a much larger depth and actually tracking every single thing that happens. Like you need interprocedural analysis, points to analysis, type state analysis, may versus must analysis. So there's like a very wide range of different things that the abstract syntax trees will not be able to give you, and that's why like the type of issues or representation you actually make on them are much more simplistic, and then if you build rules on top of them, then your accuracy level of it's much lower, so you get lots of false positives.
Got it. That makes sense. So similar to you've talked in the past on type inference and how well, it probably started way before Haskell, but Haskell I think is where it started to become popular, and then you saw Scala with it, and now you have almost every TypeScript has it, Python has it. And so what they're doing is they're looking at the program flow, and they're saying, x equals 3, a equals x, and so therefore a is also an integer. And so they're kind of tracing through. And you're saying that you need to do that kind of as a pre-processing step to actually look at the runtime flow in addition to the syntax, and all of that goes into some, let's say, connectionist structure, some type of graph.
That is correct. And the key part here is that we're actually doing this statically, right? So we don't have to actually build the code. We don't even have to compile it, make sure that it runs. We can actually track this purely by actually understanding the structure. This is where the program analysis come in. Got it. Okay, cool. That makes sense. And then it's at that point, it's just ingesting as much code as you can, looking at zillions of GitHub pull requests that say, fix array out of bounds error. There's probably, 800,000 of those in GitHub. And so you can kind of look at all of those and see what the common structures are. That is correct. Because when you actually convert it to this internal representation that we have, then that becomes purely language agnostic, right? That's kind of the best part. So the only thing that it's language specific is the parsing, and then the representation is language agnostic. So we don't care how the developer wrote it. We actually care what it does and how it actually does it. Got it. Do you look at the variable names, or is that just too much noise? So we actually have metadata that we can actually track back to what it is, because that's the idea that when we understand the problem, we can actually point to where it's coming from and what it does. But ultimately, we don't care what the variable name is, right? I mean, it could be anything. Yep. Yeah, that makes sense. Yeah, I mean, I can imagine just semantic errors. You say miles equals feet times 10 and say, okay, that's an issue. But I feel like, as you said, it's just too hard. There's just too many different names for things. Yeah, so there is a different tool that we have released, and that was during the research years, that is deobfuscation, that actually tries to predict very accurately what is the best name for each variable. Because, when you obfuscate code, you can deobfuscate it, so you can actually make it human readable. So in that state, we actually have pretty good heuristics based on pretty much machine learning, how a specific variable it's used and what it does, and then understand how people name it, and then understand what the right name it should be. That is super cool. Yeah, is that something that people can just try out? Can they just upload a CPP file and see what the deobfuscator? I think that was mainly for Java. It's a JS nice and nice to predict. Those are the two tools that actually do that, and they're free to use, so anybody can upload anything there and use it. Oh, very cool. You have to check that out. So you said JS nice? JS nice, yes. JS nice. Cool. Yeah, we'll add it to the show notes. So, okay, let's spiral back a bit to the sort of product and market here. So how do folks, in general, how do folks find bugs now? Especially, we've all found bugs, in our school projects and things like that. But when you're in these enormous
software engineering teams. So imagine you're building the Amazon app or something. How do developers go about finding bugs in these sort of monolithic projects?
Wow, it really depends. I mean, there's ultimately two major ways: the human way, like when you're using humans to do it, and some kind of automated ways. Human way is obviously a range, like while coding, like yourself, or when you're doing pair programming, you have your counterpart actually say, "Hey, what the hell is that?" So that's standard, right? The peer code reviews, I mean, code reviews are pretty common today. So that's one of the, I think, most common ways that people will actually identify issues. And then unit and functional testing that you've built or you're building as you're developing. The more, sometimes I call it old school, but it's really actually pretty popular still today, actual QA testing or QA processes, right? There's many different ones. Lots of them are still human-based. And then the very final one is you're actually customers or users testing it and saying, hey, this broke, what the hell? What should I do with it? So I think this is kind of the range of the human identification of bugs. And there's obviously many automated ways that are actually coming these ways, that using static analysis, the automatic test coverage or test generations. Then you have the wider range of formal verification or fuzzing. Then there's actually some compliance testing that could be happening. So you have some, for specific industry, there's a specific set of rules that you have to test for. Then they can cover issues. Obviously, there's dynamic analysis as well. That's pretty big those days. And there's many areas that you can catch things by just simulating the runtime of the program or actually running it live while the users are performing operations.
Yeah, that makes sense. I think as you move along that continuum, you add sort of more and more, I guess, risk or more side effects, right? So if a bug makes it all the way out to the end user, it could be totally catastrophic. Like you break the login page for your app, you might never recover from that. Actually, I know companies who, like small companies, that broke the login page and literally never recovered. And then you go all the way to the other end of the spectrum where there's a static analysis tool so that, before you've even hit save on the file, that there's an issue. And so that's obviously anything you can catch there is adds huge value to your time and to, de-risking the project.
Correct. Yeah. So ultimately, the belief is, yes, the earlier you catch it in the development cycle, it is much cheaper. I think there's an exponential growth. A couple of studies have shown that, if you're catching it after it goes to production, it costs you like thousands of times more than actually catching it during development time. So ultimately, most tools are actually focusing to try to get it as early as possible. So the developers not only identify them as they create the problem, but they actually can learn from the solution because it is fresh in your mind. You say, oh, there's a problem here. Oh, that actually makes sense. Or if you have a symbolic head that even can help you with the explanation, then it's even easier for the developer to figure out, oh yeah, that is the problem, makes sense. I know how to fix it. And you're pretty much never going to make that mistake again, which is the beauty of it all.
Yeah, that makes sense. That's so true. If you have to fix something, especially if you're under the gun because it's affecting production and maybe it's 2 months after you wrote it, you're probably not going to retain anything meaningful. And then you could just make the same mistake again later.
Yeah. Or it's very likely that somebody else had to fix it, not the original developer.
That's true too. Yeah. So what is the, in your entire career of being an engineer, leading teams, leading projects, here and abroad, or, depending on where you're listening, abroad and then in Europe, what's the biggest, most intense horror story? What's the bug that really kind of kept everyone up at night? Something that kind of terrified you?
It's a fair question. I mean, as a good example, actually, it literally kept us up at night. This is back in the early days of Vistaprint. It was the holiday season was pretty much 10 times more volume than a standard day, right? And you have to process millions of orders. So production went down. like literally, and that's very costly because a huge amount of orders that pretty much cannot go through. So we actually had pagers went up, like we had to wake up like 3 a.m. plus, and then we went to the office, and I think we spent something like 2 to 3 days, because what happened is that we actually overflooded one of our production facilities, so they cannot really take any more orders. So we really had to create the fake production facilities in a matter of like a day. And we didn't know exactly originally where the problem is. It took us some time to actually figure it out. And then we said, okay, that's really serious problem. And then we have to continue fixing it. And the fix was pretty bad because we had to make a new production facility. So we spent a couple of days in the office nonstop. It was quite an interesting experience. And we ate a lot of pizza. Right.
I'm sure you built some camaraderie, and I'm sure you never want to do it again.
That is for sure, yes. I mean, there was a lot of SQL back then. We had to write a lot of SQL migration scripts to catch that, and even today, that is not the most bulletproof language to do things in.
Yep. Yeah, I mean, I think so. Patrick, it'd be cool to hear from you too. But I have a couple. One, we were working with this vendor who is providing basically an internal tool for us. But the internal tool, this is a terrible design decision. The internal tool is using the same fleet of machines as our production site. And basically they deployed the internal tool, and about a month later, the entire site went down. And we were trying to figure out what it was. It was really hard to sort of do some root cause analysis. And what we ended up finding was this one file where, so folks out there might know, when in C++, if you append to a string and you do this many, many times, it's actually not a big deal, because C++ will just allocate a big chunk of memory and then start filling it up slowly. But in other languages, and I think this was in Visual Basic, if every time you append to a string, it makes a copy of the string. I think Java does this too. It makes a copy of the string that's big enough for the two strings you're trying to stick together, and then puts both of them there. And so this entire file was just thousands and thousands of append string commands. And the logic was all fine. So, logically it was doing the right thing. And for a while, it didn't matter, but then the memory fragmentation just eventually causes all the machines to start underperforming. And then it's one of these things where once something starts slowing down, more requests come in, people just start hitting refresh, which then causes it to slow down and it blows up. And I just remember spending just so many hours, same thing, just eating pizza. I think we worked almost like 30 hours straight. We were sleeping in the office. And then finally we figured out it was this internal tool, and then we just deleted it and went home.
Nice.
Yeah. Oh, man.
Yeah, I don't know that I have any like horror stories where I had to stay up 30 hours. I guess that sounds pretentious, not trying to be. I mean, I have tons of bugs, like you mentioned. I mean, we have one where we were dereferencing a pointer that wasn't set correctly in C++. And of course you get data. It was just sort of garbage data, but it mostly worked until it didn't. So it was mostly zeros, and then occasionally it would not be zeros and would break stuff. And it was very hard to debug because, 99% of the time it would work correctly because you would dereference an address that was just set to zeros. But then occasionally it would dereference an address that would have something else in it that would be some old not overwritten data, and then the program would crash.
Yeah, I remember.
This is a classic.
Yeah, I remember similar things, just like, after 2 hours of runtime, it would just randomly crash. It always comes out something like that. I think actually the hardest things for me lately are just issues with the data, and these are things where I think there's a lot of tooling that still needs to be built. So, I mean, one example I'm thinking of is someone made a bug in a system where they had a day and they needed to convert it to day of week. And somehow they messed that up. And so there was no Sunday. So basically all the Sundays were set to Saturday. And so there was twice as many Saturdays as you'd expect, no Sundays. And that just caused total havoc in all of the downstream systems. But again, it's not something you can find pretty easily. it's something kind of inherent in the data.
Yeah, that actually is one of the most common errors that we reported in 2019. It's date-time formatting. There's like hundreds of different ways to actually make a mistake in those, and obviously hard to figure out. And that's why we have a whole category of issues that actually detects that, which is pretty cool.
Yeah, totally. Yeah, I think anytime you can stay to UTC time, is probably just stay in UTC. Just don't print the date unless maybe at the very end.
The AM PM is another big issue in that space. I think I've had myself a couple of issues like this. That you say, okay, it's daytime, and you forget that you have to you're actually using the 12 hours only, and then you actually don't keep track of AM PM at all.
Yep. We have an issue where I think there's something about there's an extra hour. I don't remember the details, but we have an anomaly. Oh, that's right. Yeah, that's what it is. Yeah. So that we have an anomaly detection system, and to this day, every twice a year when there's a daylight savings shift, there's more or less traffic than we expect that day, and an alarm goes off. Cool.
We always had. Sorry, go ahead. No, I was going to say with daylight savings, we always had issues that during that week, there was always you're going to show up to a meeting and half of the people will not be there just because they're in a different time zone that's in a different daylight savings. That's always a funny one. Yeah,
totally. Yeah, I'm waiting for the day where they get rid of that. I personally, I like it to be later. And so they were going to, over here in California, they were going to pass a bill to get rid of daylight savings time, but somehow I think it didn't make it to the legislation or something.
EU made a vote and they agreed, yes, we should get rid of it. But then in typical politicians' way, they said, but each country decides how they want to implement it. So now each country decides if they want to use it or not. So it's still going to have some countries drag along.
Oh, geez.
Hey guys, I'm going to jump in for a minute here with a word from this episode's sponsor. We're happy again to have educative.io, an online learning resource. And since the last time we came to you talking about them, they've changed things up a little. They have a brand new option. Instead of buying courses one by one and selecting what you want, they now offer, they still offer that, but they also offer the ability to get a subscription where you can, for the length of your subscription, access any of the courses. So all the same courses we talked about before, you can now access for sort of a flat monthly or, per time period fee. And because of their sponsorship, they've agreed to give us at educative.io/programming throwdown 10% off either a single month's purchase or the subscription.
That's right. You get 10% off pretty much anything in the store.
So I was looking at the courses after we talked last time, and a couple things that I guess I missed, and which is one is they have a number of courses that are actually just completely free if you want to try them. So they have free previews, little parts of many of their courses, but they also have a number of languages from scratch. So C++ and Python from scratch. And those courses are actually free. So not only are they a great way to learn or advance your knowledge in those languages, but it's a great way to actually check out the platform first because, spending any money, I don't like spending money. So not spending money and still being able to check something out always alleviates a little bit of the sort of nervousness around doing it. And this is a great way to check out the platform, these from scratch courses. And there's also another course I found on here that's the practicing for programming interviews. So Jason, you do interviews at your company. Do you recommend people practice programming before they show up to your interview?
Yeah, totally. The cool thing about this is when you're kind of writing in this sort of environment, they kind of give you some setup, and then you write some code, and then you can even kind of validate that you've done the right thing. And that kind of loop of writing something, especially in this case, if you're unless you're sort of using an editor and then coming back, but if you're writing it in the editor, you're kind of writing that as if you're writing it on a whiteboard. And then you're getting this instant feedback, like, okay, you got it right. You need to try again. And that's really going to kind of give you that muscle memory that you need so that when you go to a whiteboard interview, you kind of are a little bit more prepared. I think the from scratch courses are really solid. And the other part of it is, it's a different way to learn. There might be some folks out there who can do sort of the lecture thing. For me, it never really resonated with me. Something like this, where it's hands-on, is really good for people like me. And it's awesome that they have this free course. So even if you're a Python guru, but you think this might be a good way to learn something else, you could dive through the Python course. You could pick a different language and dive through that totally for free. And then if that looks like the kind of learning model that's really going to work for you, then you kind of know that without having to spend any money.
They didn't really, I was trying to think about it. I guess when I was learning to program, I mostly did it from like books before even really like getting on the internet or there being internet. I mean, I guess there probably was, but we didn't really use it. Yeah. So the closest I could think of this was, did you ever do Vim Tutor?
No, I didn't.
So if you ever, have accessed Vim, one of the things it'll recognize, or I guess VI is the same thing. I'm not really good about the difference between the two. So if
I don't know either.
if you open them, sometimes at the bottom will be like, I forget, there's some command you can type, and it will basically walk you through like a document, which also tells you like how to edit, and you like move up and down in the document, and it's sort of almost like kind of like interactive fiction about learning how to use Vim. Which I still don't know.
Emacs has something similar.
Okay. And I was thinking like, actually this kind of is like that, but of course like 100 times better or whatever. But
yeah, when you originally said that, I thought you were thinking about, they actually used to have these, I keep wanting to say Choose Your Own Adventure. They're about the same form factor as those Choose Your Own Adventure books, but it's not, you read it, left to right. But you get to a point and there's basically like a little puzzle, and, you're supposed to like solve the puzzle, and then somehow there's some way to like validate you got it right. And then you keep reading. And so the idea is it's kind of on the honor system, but you'd be reading, this is just like a paperback book, and then it would be like, oh, put in this basic code and then edit it to solve the puzzle. And that's basically how I got started.
Yeah, so I mean, I think this, format is, obviously catching on in a lot of different places, and it's really awesome to see this as a learning resource. I think this will really resonate with people, the ability to be able to be almost anywhere and be able to interactively, read, write the code, not necessarily just like listening to a lecture and trying to figure out like, how do I make it go 50% faster, or how fast can I go before I can't understand the person anymore? Not that I've ever done that before. But yeah, I think this is a great forum for learning.
Yeah, this is awesome, guys. Check it out. Educative.io/programming throwdown. That's going to get you a 10% discount. And that's also going to let them know that, that this was a good slot for them, that they were a good sponsor for us. So that helps us out. It also helps you out, and check it out. Also, let us know, send us comments, send us email, let us know what you think of the courses. And, we can relay that back to the folks at Educative and give them feedback so you can keep improving.
All right. Thanks for the sponsorship, and let's get back to interviewing.
All right.
I want to talk more about how DeepCode works. We talked about from the technical side, but as a developer, what's sort of that experience like?
So there's multiple ways to use DeepCode. That's the idea, is we have a public API, and you can, in command line interface, you can really hook it up anywhere you want. But the most standard usage, as we spoke earlier, is part of the IDE. So we released already a VS Code and Atom plugins, so you can directly just get the suggestions as you code. The next stage is obviously after you commit the code, then we actually have integrations with GitHub, Bitbucket, and GitLab, where we have a bot that automatically will comment on pull requests. That will tell you, hey, you guys are doing these new things. By the way, you're introducing this issue. Please look at it. So in this case, it gives you kind of a diff analysis only on the new things. And obviously, at the later stage, you can actually add it to any CI or CD pipelines, or QA. Let's put it that way. So it really depends on the workflow that you're actually working in, but you can use it pretty much anywhere.
That makes sense. So from a usability standpoint, it sounds similar to other static analysis tools like Shellshock or Pylint or Flake or one of these things.
I mean, yeah, from a workflow perspective, absolutely the case. The big difference is that we actually run pretty much in real time. So we actually complete the analysis in like seconds, like 1 second for average piece of code, or even less. So that allows you to actually have the IDE piece, because a lot of linters, etc., when they run the IDE, it takes time to actually get results. Yeah, so that's speed is one of our main focus. Everything has to be real time for the experience to be correct, and for the people not to say, okay, I have to wait now for 15 minutes to get my results. Hopefully I get an email. Great. That's really the amount of time you save is kind of wasted by waiting.
Yeah, right. So are you running some machine learning in the Visual Studio Code extension, or are you making an RPC with the code to a server?
Yeah, it's a server-side analysis. So pretty much we have a cloud server that can do that. For larger companies, you can also have the on-premise server that actually runs it locally if you're fully behind a firewall, for example.
Got it. Okay, that makes sense. So if you and we'll talk about this. Actually, we should talk about the pricing and all that later. But if you're a student, or you're working on a hobby project, then you just turn this on. You're good to go. If you're working at, if you're working at like a military research lab or something, then maybe might not be the best idea to turn this on. And so what you want to do is reach out to Boris and get a contract for your company and get something on premises.
That is correct. And yeah, when you install it in the IDE, you can just select which server you actually want to get the analysis happening on, either the cloud-based SaaS or your own.
Cool, that makes sense. And so, what languages are supported? Is it going to take all is it pretty much everything, or are you starting with a few key languages?
So we started with kind of the top languages. So we have Java, JavaScript, TypeScript, Python. So this is live today. This month we're going to release C and C++, very likely. Hey, good news.
Cool.
And yeah, we're going to be adding a couple more languages this year. Pretty much our main focus has been to kind of perfect, making sure that we really rock on all languages that are live, rather than just add every single language out there and be just average. And we built the platform, the architecture to do so. So now adding new languages is extremely fast for us, which will enable the addition of new languages as well. Plus, at some point, there is the vision to open source it, so people coming up with new languages, which happens a lot these days, can just add it as well. Cool,
that makes sense. So, anything that's machine learning based, you have to sort of deal with this sort of 4 possible outcomes, right? So true positive means, a person made a mistake they've seen 1,000 times. You tell them about it, they fix it. That's awesome. True negative is everything else that your program is not telling people about, or things that are fine, right? But let's talk a little bit about the false situation. So, if your program tells someone to fix something, but then they kind of disagree, what do they do there? Is there a way to give you feedback in the IDE, or do they turn that one off? Is there like a / ignore or something that they can put?
Absolutely. So yeah, we definitely have / DeepCode ignore or DC ignore, which will pretty much ignore the specific instance in the line before or after. And you can actually highlight which specific issue you're ignoring, because sometimes you can have more than one on a single line of code. And same thing, you can actually provide feedback. So the way our platform is built, that once you provide a feedback, we can very quickly, I'm talking within minutes, we can actually adjust the knowledge base and either kind of expand the rule or split it into multiple rules, so it actually get accurate. So that's the beauty of the platform, that you can very quickly and very easily ingest this user feedback and kind of really push the fix to everybody else immediately.
Cool, that's so awesome. What about how are the errors surfaced? So can you walk me through that? So the machine learning system says this I guess syntax flow tree. We've seen this pattern before and we don't like it. How does that turn into something actionable, like in sort of an English format where someone can read that and grok it?
So this is one of the kind of a nice add-on engine that we have, which gives you kind of semantic explanations of the problem. This is where the symbolic AI comes in. So as we have metadata to the original piece of the code, we can kind of define gaps and say, hey, the function that you're calling, and we kind of tell you which function, and if you actually hover with the mouse over it, will actually show you the line of code and the function that you are calling, right, is getting user input, right? And you can actually see what the object with the user input is. And this input flows into some kind of an execution on the backend, for example. And we can actually, when you cover it, we'll show you where it is. And we can tell you, hey, this user input is not being sanitized by the time it gets to the execution. Which can actually cause some kind of a denial of service or path traversal or many different undesirable things executing on your backend. But that's the idea. So we actually have a human readable explanation that semantically points to each object of the problem. And you can, in the code base, to point you through it so you can actually walk it through and understand the flow.
So am I right to say there's sort of like, there's sort of this machine learning step where you are doing this almost unsupervised problem of looking at GitHub PRs and trying to find patterns of mistakes, right? But then to convert that into some sort of like slot-based language generation, there has to be like a person in the loop there, right? So is there someone on your side who's looking at the most common errors and then trying to find a symbolic representation of that?
Yeah, so we have a semi-supervised learning on this second part, which allows us to create categories of the problems, right? So we have a data flow category, for example, saying, hey, you have a user input and flows into something and it's not sanitized. So what happens here, we define this category, and then with a very small set of examples, right, our machine learning actually identifies thousands of objects that are actually doing the same thing. So we provide 3 examples or 10, 20 examples of user input functions. And then our crawler automatically says, hey, there's actually here 6,000 different user inputs that I found. So that becomes your category with 6,000 potential user inputs, right? Then you actually say what are the things or where something actually can get executed on the backend, and that becomes the category of those problems. And then you look for sanitizers, and you can have like thousands of or hundreds of thousands of sanitizers. And any combination of those 3 can actually lead to a data flow problem, right? So with very little effort from a user, you end up having with pretty much millions of combinations of problems that you detect. And this is kind of the benefit that you don't have to write individual rules. Instead of writing a million rules, within 5 minutes, you actually created a category that actually represents millions of potential problems.
Oh, that's super interesting. So I think it sounds a little similar to sort of these lookalike, fingerprint models that they do for spam detection. So, for example, someone will mark an email as spam, and so then what will happen is a system will add that to a list of seed spam emails, and then afterwards there's some lookalike system that says, does this new email share a lot of the same properties as my spam email? If so, then let's sort of add it to the spam category. And so it's almost like an active learning type thing. So in your case, someone says, hey, this, or from the GitHub pull request, you can emerge that this passing the string directly in this function was not sanitary. And so here's a pull request that adds a sanitization wrapper around the string, and you can seed sort of, let's say, a new problem with a few of those examples, and then do some lookalike type thing to find, as you said, like all of the adjacent pull requests that are most similar in nature to that one. And then if that process gave you pretty high signal, so there wasn't a lot of false positives, then you say this is sort of like a good concept, and then you can roll that out.
Yeah, and the add-on point to this is that while you create a category, since we have the knowledge base and the history of Git in memory, let's put it that way, it automatically tells you how many people have fixed such problems, how many people are vulnerable to this problem today, and you get this real time pretty much. So as you kind of create a category, you automatically say, is that an important category? And you can even look into the vulnerabilities and say, okay, am I seeing any false positives or not? So you can very quickly check if it's accurate category and it should be pushed to production. So that allows, again, within 10 minutes, you can actually create millions of rules compared to what a current rule-based system looks like.
Very cool. So, can you tell me a little bit about the scale on the machine learning side? You're ingesting just an unbelievable. It sounds like you're just an unbelievable amount of data. Do you have sort of like web mirrors running 24/7 scraping GitHub? I mean, is this something that runs on thousands and thousands of machines in the cloud? Yeah, give me an idea roughly of the scale and the scope of this effort.
So that's the beauty of it all. We have built a very lean pipelines, and we don't have to scrape, like we've obviously read GitHub once, but once you actually receive the repository history and convert it into our internal representation, which is considerably smaller than the GitHub representation, then you actually just have to look at the new changes into this repository. So we don't have to kind of re-grab everything else, right? And then our internal representation is pretty efficient. So we're talking, let's say, for all of Java, you're going to be talking like a couple of terabytes. It's not going to be much larger than that. And analyzing, let's say, all of the Java codes out there, it will take you less than a day. Everything happens quick in a RAM.
Wow, so less than a terabyte for all Java code on GitHub.
Yeah, and this is not only the tip, this is all the history. What we do, we pretty much use in memory, we have a memory index, of a semantic index of every single version of every single repository out there in GitHub. For per language, obviously, we do it.
Wow, that's amazing. I mean, that's just a treasure trove of information.
That's what you need in order to actually extract the knowledge of the development community automatically, right? Otherwise, if that's not efficient and if you cannot index it and grab it really fast, then you're kind of dead in the water, right? It will take like months to actually figure anything else. And that's one of the reasons why we chose not to do static analysis without requiring to build or compile anything, because clearly if you want to compile something from like 5 years ago, like it's unlikely you'll be able to actually build it on your own.
Yep.
Yeah.
Yeah, and then the time too to build all of that code
Correct,
would be just
yeah.
extraordinary. Cool. So tell me a little bit about well, first of all, so folks who are listening who are, in college and high school, or they're working on open source projects, what is available for them, and what's the price like?
Everything for free is the short answer. So we are 100% free for anything open source. Our motto is pretty much, hey, we are learning from the open source community, pretty much everything. We want to actually encourage the open source community to get better, be more dynamic, because then we'll learn even more. So it's fully free. So anything in the cloud, GitLab, Bitbucket, GitHub, it's free. You just log in with your account for the Git and all your repositories you can scan. You can scan anything open source. For educational purposes, the same. We've actually worked with a couple of universities already. Even some of them are developing open source add-ons, which is great as part of their master theses.
Nice.
And yeah, I think the first one that started doing that was San Jose State University. So we're very happy with the collaboration there. And it is free for them because that's the idea. We believe that students, they start using things, and over time, as they go into the industry, they say, hey, I actually need that commercially. And our tool is pretty good for people that are learning things. That's the main thing, because we explain the problems, we provide examples how other people have fixed it in a totally different settings. So it's a great learning tool as well. And actually, we're also free for small companies. Like if you have less than 30 developers, pretty much you can just start using it and nobody will ever bother you.
Cool. This is awesome. We been super fortunate to have you on the show, have ZenHub on the show, and a few other folks on the show, Circle CI on the show, and almost all of these, actually every one of these products is free for students. So if you're doing, let's say a senior design project, you're a CS student or a computer engineering student, you have a senior design project, and it's something that's going to take you 3, 4, 5 months from start to finish. So it's not a trivial project. You're working with a team. You could have continuous integration. You can have some project management, and you can have the DeepCode static analysis totally for free. And it's really going to give you students out there a feel of what it's like to work on a team, an industry, which is really amazing.
Yeah, and that's why it allows students to get into software development much easier these days, because all the tooling helps them be faster.
Yeah, totally. So what about, I'm sure this is personalized, but just kind of at a high level, how does it work for businesses? So let's say someone works at let's say bigger than a 30-person business, but not a huge giant conglomerate. So they work at, say, a mid-sized business, let's say Macy's or something as an example. How can they go about getting DeepCode, on premises, and what does that kind of look like?
Yeah. So the on-premise stuff, it happens through Docker container. So you get your custom Docker container. It takes about 10 to 15 minutes to set up. And then you have your own DeepCode on-premise server. And then you have the exact same integration, the exact same benefits than the SaaS option. And the cost there is ranging, depending on your size, I would say between $30 to $50 per developer per month. Clearly, we offer a 30-day free trial, so people can experience it, test it with their code base, see what it is, before they have to purchase. So there is a risk-free trial there as well.
Cool. Yeah, that makes sense. So now we'll jump into a little bit about the company. So is DeepCode in you mentioned ETH Zurich? Is DeepCode based out of there, the company?
Yeah, we're literally 5 minutes away from the Zurich ETH main campus. So cool. We are a Zurich-based company.
Cool. Yeah, I've been there before. It's very expensive, if I remember correctly, but it's beautiful. Yeah, I went there for a conference one time, and I'm probably going to get this wrong. You can correct me, but I think I just got a hamburger, and it was like $8 or something.
That sounds like a cheap hamburger.
Okay, yeah, it's probably more than that. But this was probably like 10 years ago. But yeah, Zurich is beautiful. I remember we took the train to, I want to say Bern, but it's been a long time. Someplace, and we did some skiing, and it was gorgeous.
Well, Bern is the capital, so likely you went to somewhere else for skiing.
Okay. I think maybe we did Bern one day and then another day. Actually, yeah, we went to Jungfraujoch. Like it's the tallest point.
Jungfrau Hall, yeah.
Jungfrau Hall. Okay, there we go. And then I think somewhere around there was this. Oh, all I really remember is it was a downhill skiing, but it was kind of a very natural downhill, and it was literally down this mountain, and it just kind of kept going and going. It was gorgeous.
Yeah, there's so many skiing options here, and yes, the Alps are so many different, like off-piste, on-piste, and long piste, and very natural indeed. Yeah,
it's awesome. So is it? So everyone's over there. So folks are interested in jobs. It would be over there. There's not like remote work or anything like that at the moment.
We do have 2 people that are doing remote work, but mostly this is when you're working on kind of the integrations, like open source things that we actually deliver. Most of the core is pretty much happening here. Because it is very dynamic, it's changing so fast that it's very hard to do the coordination. Over time, clearly that will expand. So we can have specific areas that could be worked on offline. But today there's too much talking and interactions with the team. So we like to be close to each other.
How big is the company right now?
We're 15 people, continuously growing. As I said, now we're getting roughly about 1 new person per month.
Wow.
Yeah, so it's nice and growing and very exciting because of that.
Yeah, wow. So you'll almost double next year.
Yes, and we doubled last year, but that's kind of that's the definition of a startup. Like if you don't do like 100% at least year over year, then you're not considered a startup anymore. So you have to.
That's true. Yeah, well, nowadays it's unbelievable. Actually, you're seeing a lot of IPOs nowadays, like very recently. But it seemed as though no one was going to IPO, and so it's like okay, this company's worth $60 billion. Is it really a startup? I mean, come on.
Yeah, exactly.
Yeah. So what about internships? If folks want to come there for a summer, is it kind of too early for that, or are you doing internships?
So what we do a lot of master student theses here. We usually run at least 3 at a time. Most of them are from ETH, but we've gotten some students that are coming from another school that officially become part of ETH just for the master thesis, and they actually do it. So there are definitely options if people want to do research specifically that's related to what we do, and usually on top of our platform, because that enables quite a lot of interesting topics. So we do a lot of those.
Cool. That makes sense. So as far as skills, it sounds like you're looking for definitely people who do program analysis. Also, It sounds like maybe some graph convolution or like some deep learning folks would be useful.
We have some deep learning. Yes, it's for some of the new services that we're preparing for. It's been happening. So we've had a number of GPUs here running and making noise.
All right. Cool.
But yes, so program analysis, most of the backend is in C++, obviously. But yeah, pretty much core developers as well, front end as well. We have a pretty strong team, so there's always opportunities there as well.
Cool. And what's it like to work at DeepCode? So what is something that kind of makes DeepCode unique as far as a place to work?
Well, it's definitely an exhilarating experience. You can think about it as sprinting while drinking from a fire hose.
Yeah.
So yeah, there's daily new things happening. Like you cannot even plan your day easily enough because there's new things. So internally, again, the team is highly motivated and then kind of amazing experts in the space, and they keep on innovating new solutions and methods that oftentimes even researchers actually spend years on without much success. So a lot of those things we don't even have time to publish anymore, but it is required. And then from external perspective, again, like seeing all the major companies or open source frameworks using us, it's pretty nice. I mean, this is pretty much what keeps us working late at night, as well as having developers kind of unpromptedly saying, "Hey, that's amazing! I love this. You're building guys something amazing." So that's that makes it lots of fun.
Cool, that's awesome. Yeah, I bet it's intense in the beginning because you have to figure out really like the size of the market you're in, and so I have a friend who started a company a couple of years back, and he says it's just huge ups and downs. Like it's this roller coaster rocket ship where he's just getting thrown all over the place.
Yeah. But it's amazing because you really like cutting edge stuff. We work very closely with ETH Zurich, so there's a lot of research coming from there, and new things come up all the time, which is great.
That's awesome. Have you thought about, I got something the other day from GitHub saying this, one of these old projects that I open sourced a long time ago has some security vulnerability. It was actually in a dependency of the project. And so GitHub emailed me, and then about a week later, GitHub actually sent me a pull request updating that dependency. Have you thought about basically you could do almost like an outbound marketing approach where you just ping random people on GitHub and say your code has this error, you could fix it,
So we've done small tests, like we've actually filed pull requests in Mozilla and some other places, specifically in the security space. That's obviously well regarded, and pretty much all of them for active projects were accepted. So yes, we've tested it, and we are indeed looking into making it more scalable as well.
Very cool. That sounds totally awesome. Yeah, I mean, I'm definitely going to try this. I'll have to. So actually, one question: if someone installs the extension, on my laptop, I do a bunch of hacking on random things for fun, but I also have a real day job where they don't want the source code going out of the off premises, right? So how can I sort of reconcile that with this extension? Is there an easy way to turn it on and off? Should I have two copies of Visual Studio Code? How would I do that?
So that's a common request by our users. So what happens for each project that you open, you actually get a pop-up saying, "Are you okay for this code to be transmitted and analyzed?" And you can clearly say no for the project you don't care about.
Got it.
So really, any project, so when you first install it, you have three open projects, you're going to get three separate pop-ups for each one saying, do you want to do this, do you want to do this, do you want to do this? Same thing, if you close and open a new one, you're going to get it again. Because that's, common concern, and it has to be fresh in your mind. You have to always make the decision saying, do you want to do it or not? You can also clearly disable it fully if you know that, I'm going to be working only on my proprietary stuff for a day.
Yeah, that makes sense. Very cool. Yeah, I will check this out. I think Patrick's going to have to wait until you make the C++ version. Actually, yeah, now you're doing Java, right? Or is it still C++?
No, mostly C++ still.
Oh, is it?
Yeah.
Okay, got it.
So Patrick, I'll ping you later this month. Huh?
All right. Wow, it does move fast. Wow, that's quick. Cool. So tell people how they can reach out to you. So these would be, students, people who want to get this installed at their workplace. What's a good way to reach out to you? And then also, what's a good way separately for people just kind of passively follow what you're doing, maybe on social media or somewhere else?
Yeah, so reaching to me, my personal email is boris@deepcode.ai. You can also just go to deepcode.ai website. There is a live chat there. Well, not always live, but if we are up and running, you'll be live. Otherwise, we'll come back to you over an email. On social media, obviously, our Twitter handle is DeepCodeAI. Same for LinkedIn. And I'd say with Twitter and LinkedIn, you'll be getting most of the news about us. We also have a Medium page where people can actually get our developer advocate actually pushes a lot of cool articles, examples where it is like top bugs, specific vulnerabilities. So that's pretty nice. And now we actually have a YouTube channel for tutorials, like how do you set up VS Code, for example, how do you use VS Code, how do you actually set the on-premise versions as well. So all those you can have kind of a quick walkthrough. So it should answer most of your questions.
Very, very cool. And you said, just to recap, there's a command line for folks who aren't using VS Code. There's a command line option that they would install through apt or something.
That is correct. And you can just use the command line. You can literally point to a folder and to analyze all the code there.
Very cool. Thank you so much, Boris. This is awesome. I personally am enriched by this. I'm going to try it out. I'm really excited to see what comes up. And
any feedback, let me know.
All right, cool. Sounds good. We really appreciate your time. And yeah, you folks at home, you should check this out. This sounds amazing. If you're on your drive and you didn't catch some of the URLs and things like that, we're going to post it all in the show notes. So you can just, from iTunes or whatever podcast app, you can just tap over to the description. There's a link to the show notes. You can get all the info from there. But thanks again, Boris. This is awesome. And have fun, do some skiing. And we'll reach out to you after we've tried this out.
Sounds good. Thank you very much, guys. Appreciate it.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.